I want to cover this week's code. I'm going to teach you something this week that's not taught in any class at BYU, I don't think, and it's probably the most valuable tool I'll give you in coding. It'll save your, it'll pull your fat from the fryer, as it has pulled mine many times from the fryer. All right. Before we begin, any question? I saw someone had asked questions about the quiz, question on quiz 5. I don't remember anything pertinent on this. I know next week, if I don't get to it next week, you're going to see questions about VI vector or something like that. If you see those, just ignore them. I got to get through and I got to delete them because it's a topic that's brought up that's never actually discussed anywhere in this course. And those need to go. And Bob, you had asked a question about accept and intersect. According to the quiz, they're not available. And at the time of the reading of the quiz, they weren't available. They just became available October of last year. So just pretend like they're not there and just answer the questions that way. Unfortunately, the technology upgrades faster than the quizzes do. And they still have yet to give me access to change the quizzes for like the entire class and just my class. And I get tired of making the one-off, but I know next week's the one with the VI stuff I've got to change because there's like 12 questions on that topic that just don't have anything to do with anything. It's just silly. All right. Okay, am I recording yet? I am recording. Okay, I've been recording. Okay, week 5. Last week, the reason I'm sad about missing last week is because my favorite week to talk. It's joins week. And I love talking about joins because they're super fun and they're really the bread and butter of what we do, because when you're talking about transactional databases and you're talking about, relational models, you have multiple tables, and how do you get the information out of the multiple tables into one query? So let me go ahead and share my screen here. And let me close this out here, and here's what we got. And let's maximize this. Very good. Okay, so and I really only have three queries because actually to this point I've talked about them. I'm not gonna. If you watch the video that I've put before about the Venn diagrams, I'll break out MS Paint, draw Venn diagrams. Not gonna do that tonight because I got to get to the stuff for this week, which is equally important. But I just want to show you these different joins and how they work, and just so you understand them. Number one, the union. This is cute. It doesn't really help anything. So let's say if I had like 2 queries, right? And I've got this query that's select last name, first name from actor, where actor is like R. I run that, I get my results, it's great. I want to do from customer last name like R. I do that, that's great. Now, if I have 2 queries that have the same amount of columns in the select statement, I can use a union or union all to join them together. So if I do this with union, let's see, right now, if I do both of these, I got where last name for actors is R from actors and where last name is R from customers, and I run them at the same time with the union, I get one result table back with 42 rows returned. Okay. Now you might ask, what's the difference between union and union all? If I just do union, oh, it's lying to me. If I do union versus union all, there's no duplicates. And this is not doing what it's supposed to do, which is fine. I'm okay with that. What 2 rows returned? If I do this, that's not working. Anyway, so, but here's the thing with this, with actor. So I do a last name. If I go here and change from first name to, let's go to customer because I think it's more interesting. Columns, yeah. So if I go here to customer and I get rid of first name, and in here I put email instead, it still works, right? So this is very not smart. It just says 2 columns, 2 columns, I can return them. Okay. It's a very, very it's like using a sledgehammer to open a coconut, right? It's a good idea at the time, but we don't want to use this too often. I still don't talk about intersect and accept because it's really not part of the curriculum, even though they're there. Because the curriculum hasn't changed, I'm not going to bring it up because I don't want to confuse you guys and have you answer questions like, oh, they exist when the quiz says they don't.
What
don't like-
was that with the quiz? I think it was this week, wasn't it? That talked
Yeah.
about.
Yeah, I think it's this week's quiz. No, it was last week's quiz. This week's last week's.
It's week
There-
5.
It's no, I know it's week 5. I'm trying to remember if it's the week 5 or week 4 quiz. There's a quiz. There's a part of the quiz that says something about using the accept or intersect commands, and the answer is they don't exist in MySQL. And when the quiz was written 4.5 years ago, they didn't exist in MySQL, but now they do as of last October. So just say they don't exist.
Okay, because I don't know. I think I sent you a message about those quiz questions because I answered
Yeah.
them, but some of them, like there were 3 of them I got wrong, which isn't a
Yeah.
big deal to my grade. But I was just wondering how, like, what.
Yeah, I gotta go back through the. I got your email. I just haven't gotten a chance to go back through the quiz yet because I'm very behind. I'm normally not this far behind my grading on week 5. I'm only halfway done grading the week 3 papers.
Okay,
So
no worries.
yeah, luckily I can churn through them pretty quickly. I just have to sit down and make the time to do it, and I got to do that this week because I don't want to get 3 weeks behind. Because it'll make me crazy. So there are 3 kinds of joins. There's inner join, out left joins, and right joins. So the inner join, I'm gonna have to do the Venn diagram. MS draw, MS paint. That's fine. Okay. I don't know why I avoided this. I love drawing these things. Show my mad skills when it comes to MS paint. All right. So let's give me a circle here. Do. And then copy and paste. Give me another circle. No, copy, paste. Thank you. Nope. Give me another circle here. All right. Where's my little paint can? And we're gonna make you red. And we're gonna make you. I want blue. Blue. All right. Okay. Boom. And we're gonna make you yellow. Okay. So when we write an inner join, we change the color to black. What's returned is any value that exists in both tables. Okay. So if the value exists in both tables, it's there. 90% of the time when you write an inner join statement, you're gonna join it on a column using the on command that has a foreign key between the 2 tables. You do not have to. You do not have to use something that has foreign key. You can use 2 things that have nothing to do with each other if you just want to confuse people. So you don't have to do that, but generally speaking, you do. That way, you're only getting the things that match. When you talk about right and left joins, this is your right join. This is your left join. Okay. When you do a right join, you return everything that matches plus everything else that's in the right table. With a left join, you return everything that matches and everything that's in the left table. So looking back at our queries here, I got quizzes. Yeah, okay, David. Yeah, I got to go through the quizzes. They're a bit of a mess. And they always will be until let me change them. Okay, so here, select at last name actor, last name from as actor, last name is customer. From actor, left join customer on actor's last name equals customer's last name. Now, obviously, these aren't foreign keyed because you wouldn't foreign key that. That's crazy talk, right? So what's going to happen is the one that's on the top is considered the left table, and the one that's on the bottom is considered the right table. Because if you did it that way, it'd be like this. So if you did it in one line, so this is the left table because it's on the left, and this is the right table because it's on the right. But it doesn't like to look like that. It wants to look like that, right? So when I run this, it's going to have all the names from the actor table and then a bunch of nulls from the customer table where they don't match. So here, there's no Ackroyd in the customer table. There's no Bacall, there's no Bale, Ball, Barrymore, Basinger, things like that, right? So it returns everything from the actor table and only where it matches from the customer table. If I reverse that and use a right join, it'll be the reverse. So here, I have no Abneys, I have no Adams. And I have all these, like if I go down here, the one that, yeah. So it shows me where they don't match. And only commonly here, there's Cruises in both. There's Davises in both. There's Deans in both. Okay. There are practical applications for these. For example, if you're trying to do something with inventory to see if you're missing things, you want to do a left join. If you've got a table of what you should have, if you had a table that was like optimal inventory and you had a table that was current inventory, you do a join between the left join to see what was missing from your inventory, things like that. In everything other than MySQL, there's something called a full join. And that does what you think it would do. It returns everything on the left and nulls where it doesn't match and everything on the right. So it just, I don't know if this will work. No, it won't work. No, that won't work. Maybe it will. Maybe. No, it doesn't like that at all. Yeah, that's fine. Anyway, so it'd be essentially unioning it. So you'd get all this and all this, the nulls on the side, but that doesn't exist here. Okay. So those are the joins, and I kind of gloss over them here. It would have been a much better show last week had I done this, but we talk about joins a lot. Every query I write from this point in time will be joins. But right now, is there any questions on joins? Everyone good? Got a chat question here.
Yeah, I have a question.
Hey, me.
Is when it says left join, does that mean that it's the first table that's listed in the select clause?
Yeah. So here, if you do from actor left join customer, actor's the left table.
Okay.
Okay. It's because if you did everything on one line, actor's on the left. Actors there and customers there, so that's what it is. But yeah, whatever the first table is would be considered the left table. Okay. Any other questions on joins? All right. So now on to fun stuff. And a lot of the stuff I'm going to talk about today, there are two very specific things that I talk about today that we don't cover anywhere else here. So the first thing is we don't really talk about the code to create a table. So I'm creating my own table here, and I've misnamed it because we never pluralize table. Okay. So I've got table person here. Yeah. Okay, it's not there. Yeah. So I've got create table person, and then here I've got the first column in person ID. Did I give you guys the video when I go and do get on the soapbox about data types and why we choose specific data types? Did I get into that soapbox with you guys yet?
I don't think so.
Okay. So real quick sidebar. Tiny int, small int, big int. Okay. 32, 16, 8, 4. Okay. Now I'm going to guess these numbers. This is like negative 500. I'm guessing at these numbers, but this will give you a rough idea. There's somewhere there's a chart that I sent out for this, and this is like negative 32,000 to positive 32,000. And then this one is like Negative 2.6 million. Okay. And this is like, whatever you want it to be. So you've got four, and all the data types have various sizes. So there's four types of integers. There's tiny int, small int, and big int. And the difference is the size they take up per row. Okay. A tiny int takes up 4 bits. A small int takes up 8 bits. Big int takes up 16 bits, and big int takes 32 bits. And you think to yourself, that's not a big deal. Okay. So there's two things you got to keep in mind when you and I have somewhere there's a video on my YouTube channel, like and subscribe, that has everything to do with choosing the right data type, and not choosing the right data type from the start won't hurt you, but 7 years down the line, it will come back and bite you hard, and it'll be venomous, and you'll be in the hospital. And I'm going to give you a story about that in a second. So with a tiny int, the range of a tiny int is negative. It's around negative 500 to positive 500. So if you try to do 501, it wouldn't work. It's too big because it exceeds the bit limit, right? Small int is like negative 32,000 to positive 32,000, so on and so forth. If you try to do 32,001, it would fail. You get an out of limit exception, right? And whenever you see the term out of limit exception, it means because whatever you're putting in there is too big for the value that's there. 16 int, an int is 2.6 million to positive 2.6, and a big int is whatever number you could possibly think of will fit in there. We haven't run into a number that it won't take. Years ago, I worked for a company, and this company was a property insurance company. And what they did is they got data on every piece of property from every county in every state in the country. So they could look up any piece of property anywhere. And what they would do is they would charge people to come and look at this stuff because it was one place for everything. And it was brilliant, right? So when they started the company, they started this thing, they created they created a database to keep track of the transactions, right? And they used int as their auto number field for their transaction table. And they thought that was a good idea. 5 years later, when I went to the company and I started working there, they were at like 2 million rows, and they only had like 600,000 rows left, and they were growing by about 15 to 25,000 rows a month. So they were running out of time because they were more popular than thought. Now, so what did they have to do? They had to change from int to big int. Now, two things are going to happen there. One big thing, that table that was there was roughly 45, no, let's say it was 500 gigabytes, right? So when you change from int to big int, you doubled the size of that column. So you went from having, let's say it was 200, let's say it was 2 million rows. You went from having 32 million bytes to 64 million bytes, which is a substantial change. So when we changed that data type in that table, it took 4.5 days and doubled the size of the database. Right?
Wow. Yeah.
It was fun, let me tell you. And we tried a couple different ways. We actually had to we had to do it off over a holiday weekend. We took the database off Friday morning, and it came back up online Tuesday afternoon. So we actually had to go down for 1 day, because it was a holiday weekend. One day, Friday, there was no word that we couldn't make any sales on Friday. But it was a substantial thing. It was a substantial thing to do. So it becomes very important when you choose your data types to make sure that, it's valid. And, assume the worst, assume the best. Like if you're doing a table and the table is like, it's a colors table, it keeps track of colors. It can be a tiny int. I don't think there's 500 colors. I don't care what you see in the Lowe's section of the paint. I would say there's like, 500 is a good number for colors, right? But if you're doing transactions, I would err towards a big int because you want your application to do well, right? Customers, I'd probably use int. It'd be great to think I had more than 2.6 million customers, but it's pushing it, But you gotta choose very wisely with that. Okay, anyway.
I do have a question about that because I've been making my surrogate keys
Mhm.
unsigned. Does it make any difference?
You're making your surrogate keys unsigned.
Right. So if it's a primary key, but it's surrogate, because isn't that what they're called? I don't know. Anyway, so if I know it's gonna, do they start at 0 or do they start at negative 32,000 and just count up, or how does that work?
So so it starts, so whenever you do a key like that, whatever the first number you put in it is, if you use auto increment here,
Mhm.
whatever the first number you put in is what it will start at.
Okay.
So
So if I don't initiate it, does it start at 0 or does it start at?
we'll play with that. We'll play with that in a second. I'll show you what happens.
Oh, okay.
So now, okay, so here, that's a great question. So in MySQL, you've got to tell it where to start. In Microsoft SQL, it's not called auto increment, it's called identity. And in Microsoft SQL Server, you can't put a number, it won't let you put anything in. But with auto increment, you have to give it a starting point, and we'll play with that and see what happens here in a second. But that's a good question. So here we got int, got not null, which means it must have a value, right? And then auto increment, which means it will look to the previous row and add 1 to that. Okay. Last name varchar 255. So varchar means, so the difference between char and varchar, if I do varchar 255, it means that column can hold up to 255 characters per cell, but will only register what's actually there. So if you put 4 characters there, it'll have room for 255, but it's only going to take up space for 4. Okay, so it can grow later if it has to, right? It's kind of like if you have a balloon, right? And the balloon can blow up this big, right? But you only put this much air in it, it only takes up that much space. Okay, if I did char instead here, someone hit insert when they were. If I did char instead, it will always take up that size. Even if you only have that much in there, it will always take up that size. So if you say char 255, that column will always be 255 characters big, no matter what's in there. You have like a period in there, and it takes up the entire space. So it is not a very efficient data type. I've got last name varchar 255 not null, first name varchar 255, I'm allowing that to be null. Age is an int. Actually, I could do age as a tiny int because no one's living to 2.6 million years old here. So let's fix that right away. And even if I live to 2.6 million years, the Earth won't be here when I'm done. So hopefully I'll be somewhere else when that happens. All right, and then I'm making the primary key is personal ID. Okay, so I create the table, and boom, the table's created. How exciting is that? Get rid of all this stuff here. Now, I'm not really sure what's gonna happen if I do this. So now, Normally I go into this whole thing about like insert into persons and then values and not putting the columns here. I stopped doing that because I don't care. I'm sorry. It is very important that you always put the columns there. You don't have to. It's not required, but it's better if you do, because then it's easier for you to understand what's going on. Because I have lost hours of work trying to figure out why my insert statements aren't working when all I do is count how many columns we're going into versus how many columns I had data for. And I couldn't figure out what it was. Okay, so here, let's do my select from person. Select star from person. And I got to change this to person because I'm fixing the code as I go along here. And if I do this, it numbered it automatically. So it started with 1. Okay. If I did this and whatever the next one I put in, if I do these. So I did insert into last name, first name, age, Williams, Venus. And then this is just a way to get a random number between 1 and 185, I think. Floor, random, 25 times. It's a party trick. Don't worry about what I just play with it if you want. You'll have the code. It's just a fun way to generate a random number. And I need to come up with random ages. So if I go here and I create these. Now, if I have now here's the point of this one is if I have multiple things that need to get inserted, I don't have to use this every time. I can just do values, comma, values, comma, values, comma, and just put all these things here and it will work. Oh, that errored out because there's no person table. So here. Okay. So now I just have the one insert statement, the 4 value statements, and everything's there with random ages. Oh, look, the ages aren't being very randomized, are they? That's disappointing. Is my random function not working? There we are. So way 1 to do insert. Now, before I do this here, I want to look here real quick. I've got 1, 2, 3, 4, and 5, right? I'm going to do something real quick, which I'll talk about later, but I'm going to go here. I'm going to say delete from person where first name equals Andy. Nope, Willie. Okay. And if I go here, Willie's gone. If I run this again, if I just run this one here with Venus, let's change this to Willie. And run this. Notice that the new one is 6 and 5 is skipped. The old Willie was 5. The new Willie is 6. Okay. It does, if you delete columns, it does not reuse an ID. That is a self-preservation feature in the data in all RMDBS systems, because they don't want, if you delete an ID and you didn't delete it everywhere, you're going to confuse things and connect things the way they shouldn't be. Okay. So once you've deleted an ID, it will not reuse that. You can force it back. You can absolutely force it back. I can go here and take this here and put this here, comma that there, and put John Boy, Johnny, and I can put here 5 and run this. I can force it back into place, but if I don't do that, it will never reuse an ID. Okay. I can also, so I've got here, I can do one value at a time. I can do multiple values at a time with one value statement, all these things. I can always use a subquery. I can also take this query here, and I'm getting the first name and last name from active table and adding a fake age to it. I've got this command here called lower. And what that command does, it just takes everything in that text area and makes it lowercase. Okay. So if I do this, I've got 200 rows. If I run it now, I've added 200 rows. Oh, that's because I did it again. I've added 200 rows to my person table. Okay. Everyone with me? All right. Now, I want to alter the table. I want to add email. I suddenly realized, well, it's 1997. All of a sudden, everyone has an email address. Oh no, I've got to add email address. So I'm altering the table persons, and I just do the word add and what address what valid I want, just there. And now, oh, because I did persons again. And now, if I look here, select from persons, person.
Can you do that same thing with the ERD thing that we've worked with before? Add
Oh,
another.
it's even easier. It's even easier with the ERD. You just type it in. I'm
Awesome.
doing everything by code now. When you're doing the ERD, you can add columns whenever you want to in that, without a problem. I'm just showing you the code that does it. So I do select from person. I now have this column that's all nulls for email. So I want to fill that up, right? So there's the update command. So when you did insert, it was insert into the table you wanted to, the columns you wanted to insert to, and the values that were supposed to go into it. When you update a table, you say what table you want to update, what column you want to update using the set command, and what you want it to be. So in here, I'm getting cute and using fun commands here. I'm setting the email to concat. So I don't know if we used this command before, but what concat does, it concatenates multiple text values into one value. Okay, so here I'm concatenating the first 4 characters of the first name, adding an underscore, the first 4 characters of the last name, and then adding gmail.com. And I'm making an email address. Okay, so if I just ran this as a select statement, that's what I would get. I'm just making an email address for them. It's not how you'd really do it. You get their real email address, but you know, this just gives you an idea how to update stuff, right? So I'm going to go ahead and update this and bring this back to a little asterisk here. So it's select all. I did it again with the person. Okay. Okay. Update person. Show me my stuff. And I've done this. And I've just proven why we don't like people doing things by hand, because I misspelled gmail.com and gmail.com doesn't exist. Oh no, oh dear, whatever will I do? I can also do this. Here's a fun one. Update person, set email, and use the replace command. I will say replace in the column email, find where it says this, and change it to this. So we'll go through the string, find where that exists, and change it to that. We run that. It fails because it's still persons there, and I haven't figured that out yet. I go here, and now I look at this, and now it's an actual email address. This is an important thing to do when you're fixing data. The replace command. So you just can find the one thing that's wrong and fix it. We can use where clauses in our update statements. Update person, set first name into uppercase where first name, where age is between 12 and 25. I run that. And I do my select from person. And I see some of these are set to uppercase. I can also use inner joins and outer joins and left joins for this. Update person, join into customer, on person last name equals customer last name, and where those match, I'm setting the age to 999.
When you use replace, is it just for the data that you've entered, or can you change data types as well?
No, so replace only changes data. You have to use an alter table command to change data types. So if the replace just, this is a DML command. So this happens in the DML, and this is DDL. So this defines the data, this manipulates the data. Okay. So yeah, replace it for only for the inside. Was there no? That's just, I thought there was an age at least.
Your other, when you ran the other thing, it had an error.
Or did it?
Yeah.
What was the error? Oh. It's still pluralizing. All right. And there we go. Out of range. Oh, look, I told you, out of range. Because I changed that to tiny int. And 999,000, whatever that number is, it's late here, doesn't exist in tiny int world. So I'm gonna change that to 99. That was a unplanned error that I should have showed you, because it's a good point to bring this up. A lot of times when you get an error in Transact SQL, it tells you exactly what's wrong. This says out of range error for column for age at row 1, which means whatever you're trying to put in there is too big. And now when I do this, it's fine. And 49 rows were changed. And let me just find out where my 99-year-olds are. There we are. Okay. Now this, everyone good so far? This is the part that I show you that will save you if anything goes wrong. At least a dozen times in my professional life as a DBA, I've went to make changes on a table and I've done something like this. And I've run it without the where clause, which is a bad thing. Because I don't want to change everything. And it's easy to make. Human error is a very easy thing to do. So we can fix that. We have this command called start transaction. Now, I don't know if I talked to you guys about transactions, but whenever you execute something in code, all that code that you're submitting is considered one transaction. It just bulks into one thing. So if I ran everything here at once, one transaction is done, right? I can explicitly start and end transactions. Okay. This isn't going to work. So let me go here and do this to, I think that should work. Ooh, not 1,000. Okay. So if I use a start transaction, it means anything that follows this is considered part of the explicit transaction I'm creating. And then I've got one of two choices. Now, what this does when I run this, I just run this right now, okay? This is locked to my database, which means no one else can use my database right now. Because I've got everything in a transactional state. So anyone else who's trying to use my database right now is gonna have a really hard time getting in. Right? So we don't want to do that. So we want to make sure that these are fast. Okay. So I start the transaction and then I run the code that I want. What happens is, did I talk to you guys about transaction log versus data log, the database itself? Did I talk about how oh man. Back to MS Paint. Okay. I miss having a whiteboard. Okay. Okay, so drawing some stuff here. This is my database, okay? This is my computer. This is my transaction log, and this is my database. And I'm gonna make them different colors. We're gonna make the database blue. Come here. Database blue. Nope. Come here. Thank you. We're gonna make the computer red, and we're gonna make okay. So here's what happens. Give me a pencil. I am working on my computer. Remember, like I said, I can only alter data that is in memory. I can't touch anything on the drive. I know I said that at least once. I've now said it twice. Okay, so I'm making changes on my database here, and I submit those changes. So I go, okay. When I write data from my computer, I do not go directly to the database. It doesn't work that way. I go to the transaction log. So my computer writes the transaction log. The transaction log then writes the database. Okay, and here's why this happens. Let's say I've updated 10,000 rows in my database, and I submit that change. And let's say, for sake of argument, it wrote directly to the database. Okay, what would happen if the power went down when I was 5,000 rows in? Nothing good. The database wouldn't know what was the last thing to do. It would have no idea what was going on. It would have no way to check itself to see if anything was, it would have, the data would be corrupt. Absolutely 100% corrupt. Because it would not know that there were 5,000 changes left to go. Right? So this is how databases write. Can I do this? Okay. So let's say I've made 10,000 changes on my database and I send it out to be completed. The first thing that happens is the computer tells a transaction, sends it out, says, I have changed 10,000 rows. And then it starts sending the rows. And it sends it to the T log, the transaction log. It is recorded in the transaction log. And then it starts writing to the database. So it's here first and then into here. If at 5,000 rows, this dies, and when it comes back up, the database is going to go to the transaction log and say, hey, there's something called a what is it? No, what's the term? What's the acronym? Just call it an ID. So the database knows what last entry it got stored into it. So it's got an ID column that tells you what the last one was. And the database looks at T log and said, hey, the last entry I have is number 6,742. And the T log goes, wait a second, Mine is 7,012. You're missing stuff. And then one of two things will happen. The T-log will then look and say, okay, we were in the middle of a transaction that was bringing 10,000 rows. You got 5,000 of them. I have the other 5,000, and it picks up where it left off. If it was down for an hour, it would come back and say, you're missing 5,000 rows. Here are the 5,000 rows, and it would continue going. The database would come back up as suspects, but 15, 20 minutes later, everything would be fine. If for some reason the full 10,000 rows weren't written over here yet, and not here, so when it comes back up, the T-log goes, hey, you got 5,000 rows. There are 5,000 more, but I only have 20 of them. Roll everything back. So the T-log takes all the 5,000 changes and erases them from the database as if they weren't there. It is the self-preservation that RMDBS systems have. Okay, and it happens that way because this is transaction based. This is the transaction log. It keeps track of everything that happens transactionally. If a transaction does not complete, the database looks to the log to see if it has the complete record. If not, it rolls back to the changes to the last time it was perfect, and then notifies the user, hey, we had to roll back everything back. It wasn't here. If it's all here, it pushes it forward and completes the transaction. Does that make sense to everybody?
Yeah. So if it didn't complete, and somebody tried to access that data, it wouldn't be live. They wouldn't be able to see it.
No. So what would happen is, in the case of when a database suddenly comes down, when it comes back up, it comes up in what's called suspect mode, which means no one can see it, and it's in the middle of checks.
Okay.
It's doing health checks, and until it's fixed, no one can get to it.
Okay.
Okay. So that's what transactions are about. This computer sends a transaction to T-log, T-log runs the database. Anything happens, it goes back and tracks it here. Okay. And you can do a lot of fun stuff here. You can in the T-log, if you can see who did what, when, where, it's a whole security thing. I'm not going to get into it. We can go down a rabbit hole, and we'll be here until sometime tomorrow talking about what you do with the T-log. But the important thing to understand is how transactions work. Okay, they're capsulized data changes on the database that can be tracked and monitored and managed.
And does the T-log wait until it gets everything from your?
It's buffered. It's buffered.
Okay, so if that goes down, it would back it out as well, right?
Yeah. So what would happen is, let's say, so it's buffering. It's usually about 20 to 30%. So once it's 20 to 30% of the transactions, it starts pushing it to the database. Right. It doesn't completely write to the T-log, and then it buffers it out. So that's why, like, it may not know everything that's supposed to be there, and it'll back everything out. But yeah, it's I wish I remember the acronym for the ID column, but it's escaping me right now. Okay, so everyone got that. So back to what I'm talking about over here. So I can explicitly set a transaction in my code. And what this allows me to do, so let's say I want to do this thing where I set age to 100. I start the transaction, I run the code, and then I've got two commands. I've got rollback and I've got commit. If I do this with rollback, it'll show me that 49 rows were changed, but then it rolls back to nothing ever happened. So this will confirm to me what was changed, how many rows, but it will not make the change until I issue the commit command. So if I were to look at this right now, no one here is 100 years old. If I do the exact same thing and use the commit command instead, now people are 100 years old. This, if you're ever updating against live databases and you are not using transactions, this is going to bite you. I have probably broken production databases 24 times in my life because I didn't do this. And you'd think I'd learn out the first time. Took a few times. But this is a very, very valuable tool for a developer. All right, moving on. So we've talked about inserts, adding data. We've turned up updates, deleting data. And now we're going to talk about the last two commands about deleting data. Again, it's delete. Delete from persons where last name like W. Again, we've got a where clause. Now, if I did this, it would delete everything from persons. And again, I've done that. So make sure you highlight everything. Delete from persons where last name like W. I run that. I change it to person because it won't work with persons. Boom. It's deleted 25 rows. Delete persons from person. Delete person from person. Inner join customer where person last name equals customer last name. I can use inner joins in delete clauses, delete commands. It will, if I allowed it to commit, it would have deleted 32 rows. Give it a rollback and then commit it. And we deleted 32 rows. Okay, everyone good? Last topic of the night, and then we're good to go. Truncate. I don't know if I talked about truncate before, but I'm gonna give you a quick truncate. Remember I talked about the transaction log. When I ran this delete command and it deleted 32 rows, each of those rows was earmarked in the T log. So it showed which rows were deleted specifically, all 32 of them. Okay. When I did this one and it deleted 20 some odd rows in the transaction log, it showed all 25 of them one at a time. Because when you run a delete command, it looks at every row in that table and decides whether or not it's supposed to be deleted or not. It goes R bar, which I don't know if I've said R bar a lot. R bar stands for row by agonizing row. So it's going no, 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 yes, no, 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 yes, no, no. Truncate just flushes everything without looking. Just empties the table. Doesn't care. And in the T log, all it says is truncate table. So you have no idea what's there. It is like it is nuking the table.
Is there any situation when you would want to truncate the table?
Oh, absolutely. Oh, absolutely. Absolutely. Let's say you had to migrate the data from one table to another and you kept it there to compare before it was done, and you just truncated the table on the other side. Truncating tables is something you do more often than not. You just need to understand the difference between the two of them, because deleting, if you know how to manipulate and utilize the transaction log, if you delete something, it's recoverable because you can actually go into the transaction log and find what you deleted and put it back in the table if you know how to do it, right? If you truncate, it's unrecoverable.
That's cool.
Yeah. So there's times when you use all the data, we don't need this table anymore. Truncate it, boom, get it out. a lot of times in your like non-prod environments, your test environments, you're manipulating data, playing things, you create a table, you fill it up with data, you mess around with it, you want to start over, you just truncate it. Like with my person table here, I truncate this quite a bit because, I mess around with it. And what I don't know what'll happen, and I'm curious about this, is I'm going to take this. I'm really not sure what's going to happen. I'm going to put it here. And I wonder if a rollback command will stop a truncate. I've really never tried this. So I'm curious. I think it should, but I'm not 100%. So let's see what happens. It didn't. Putting a truncate in a transaction doesn't stop it. You can't roll back from that. Interesting. Interesting. Which makes sense because the thing is, when you're doing a transaction, the reason why you can roll back is because it was all in the log and it went back. It reran the log and put it back. Truncate table is not a logged action. That's a great example of that. I don't know why I never thought to do that before, but that really explains that truncate is not a logged action. It is a permanent death sentence for that, the data in that table. All right. Well, we are almost at time. I didn't have time to do a lot of database design. Starting next week, half the time will be to designing databases, and we'll go through. We'll start designing databases for fun. Does anyone have any questions on what I covered tonight? There was a lot of it, and about half of it is pertinent to the test and the quizzes. The other half is just like, as you go into the world and need to learn how to do things, transactions and truncate and everything is that. Questions, comments, thoughts, concerns? Overwhelmed? No? A little bit. Yeah. Not yet. Yeah.
It seems okay.
Still
Alright,
got
alright.
one now.
Pretty
but one.
standard.
Okay.
I find
ahead.
this easier than Python. to
Oh
be
yeah.
honest.
Oh, it is because this is English. Python's not English.
Yeah. And I also like how it tells you exactly what the error was, where in Python sometimes is way trickier than that. Or web
Now-
development.
Now don't get spoiled because that's not the way it is. Because I know I was dealing with this at work the other day, my day job, the Oracle team, there was like error 64. And normally what you can do is you can take the error codes and look them up. You Google them, it'll tell you what the error code means because everything, it was like Oracle error 64. And it came up and said, this is a code used by Oracle development teams for something they don't talk about. So there you'll get some really wackadoodle errors. I know I have, and that's when you open tickets with Microsoft or Oracle and say, hey, figure this out. And they're like, we don't know what it means. That always makes me feel good when I've got to call Oracle to fix a problem. They have no clue what I'm talking about, which makes me feel much better myself that I'm not like a horrible DBA. But yeah, for the most part, on the simple things, the error codes say what they mean. Out of range exception, divide by zero exception, they're all there. But you get the weird ones, like, when you start seeing things that say semaphore lock. And I know what that is now, but it took me 20 years to figure that out. And there's no definitive answer to what a semaphore lock is. And it's not what you if anyone here knows, I mean, other than Bob and I, anyone here know what semaphore is? I'm assuming Bob, you and I are about the same generation. Anyone else know what semaphore is? Anyone here at Boy Scouts?
Is this having to do with parallelism and concurrency?
No, semaphore is when they did the flags on the boats. So signal things. It was like the manual version of Morse code. Yeah.
Gotcha. Okay.
Yeah. And you're like saying, so what does that have to do with the database? One database is not signaling to the other, you know, but it has to do with how the transaction is talking from how the memory is utilizing the disk, the drive through the transaction on the threads.
Oh,
Yeah, that hurt your brain there, Thomas. I saw that. I saw that click. I saw that click. Anyway, forget what I said about semaphore, but like I said, some of the errors will be very obvious, and some of like anyway. But it is way better than Python or any programming language for that matter. I developed in C# for a long time, and the errors you get there are like, I don't know what you're talking about, man. And all it is you forgot a comma somewhere. The bane of my existence in T-SQL programming is the parentheses. When you start to use a lot of parentheses and you can't figure out where one is missing.
Mm.
Yeah. Anyway, I digress. All right, we're in week 5. You guys are doing great. I will catch up with the grading. If you're concerned or curious about your project topic, just ping me an email or ping me in the chat, and I'll give you the thumbs up or thumbs down. I don't think I've ever given anyone a thumbs down on an idea they had. I might say it's complicated, tone it back. But other than that, you know, this is your party, man. You do what you want, and I'll see you through it. All right. All right, I'm gonna call it a night. You guys take care, and I'll see you next week.
See you next week.
Bye.
Thank you.
Thanks, brothers.
You are very, very welcome.